3. Now, these equations, we've done a little bit of this using mental math, things of that nature. This one is going to be obviously more expanded. It'll include positive and negative situations. It'll only deal with addition and subtraction. We'll cover multiplication and division, I believe it's Thursday. Before I forget, tomorrow when you come to class, make sure you bring your phones, iPad, whatever you have, any kind of device you have. We're going to be looking at an app tomorrow that I want you to try to download. So make sure you have those when you come to class tomorrow. So the app we're going to download will sort of help us in some of the stuff that you're doing here for the next several days. All right. Now, when we're solving equations, solve an equation with addition or subtraction, you must do the inverse operation. Okay, the inverse operations, addition, the inverse would be subtraction. For subtraction, obviously, then, the inverse would be addition. Okay, so we're going to use basically the operation that undoes the other operation. To undo addition, you've got to use subtraction. Okay, to check addition, you've got to use subtraction. To check subtraction, you must use addition. Okay, in other words, if I have something simple, 5 plus 4. 5 plus 4 is 9. Okay? To check that, to make sure it's right, you would say 9 minus 5 equals 4. So that was correct. Or you could say 9 minus 4 equals 5. That is correct. Okay? So, subtraction undoes addition, and addition undoes, I don't like that word. They use it in the book, but it's sort of like, I'm not the best grammatically speaking person in the world to begin with, and we use the word undoes, and it sounds even worse. But that's the word they use in the book, so I'm trying to use the same one that they use. Now, when we do the inverse operation, when you use the inverse operation, to solve an equation, you create an equivalent equation. Okay, I'm going to show you what that means here in just a second. Okay, so let's look at a very simplistic example. Y plus 4 equal 22. So some number, I add 4 to it, and I get a total of 22. Okay, now, how we're going to solve this problem is we're going to use the inverse operation. When we want to solve an equation, we're trying to get the variable isolated in the equation. When I isolate something, what do I do? If I'm going to isolate Brandon from the class, what am I going to do? Put him in the hall, put him in the corner. I'm going to make him off by himself. Okay? Same thing when we talk about the word isolate in dealing with mathematics. When I'm trying to isolate the variable, I'm going to try to get the variable on one side of the equation by itself. To do that, I must move the plus 4 of the equation. Okay, I must move that. Okay, I must move the plus 4. To move it mathematically, we have to do the inverse operation. So here's what it's going to look like. You're going to have y plus 4, and then I'm going to subtract 4 because that's the inverse of adding 4, equals 22, and I do the same thing to the other side to create an equivalent equation. Okay? Now, on the left side of the equation, when I add 4 to a number and I subtract 4 from a number, they cancel each other out. Okay? So in other words, if I take 10 and I add 4 to it, when I take 10 and add 4 to it, I get what? 14. When I take 14 and subtract 4 from it, what do I get? 10, the original number. Okay? So they cancel each other out. Okay? So on the other side, on the right side of the equation, I have 22 minus 4. What is 22 minus 4? 18. So my answer to this equation is y must equal, or the value of y is 18. Okay? Trinity? I didn't add another 4. There's only one 4 up there that I'm adding, and it was already there to begin with. Now, I subtracted 4. The reason I'm doing that is because that's the inverse of adding the 4. This is the inverse of that. So to solve it, that's what I do to both sides. Okay? The other thing that we need to remember, I'll get to you in just a second, Brandon. The other thing we need to remember is, an equation is like an old-fashioned scale. Okay? If I've got a certain amount of weight on this side, and my equal sign is in the middle, and a certain amount of weight on the other side, if I subtract 4 from this side and don't do it from the other side, the scale drops. Okay? So whatever I do to one side, I must do to the weight on the other side of the scale. That's the only way the scale stays balanced. Okay? That's why this right here makes an equivalent equation. When I subtract 4 from one side and I subtract 4 from the other side, it creates an equivalent equation. Whether it solves it or not, it still creates an equivalent equation. Okay? Other questions, Brandon? What was your question?
Like most of them, are you able just to think of it in your head instead of doing that?
Okay, so what is 3/4 W plus -5 equal -32? Since you want to do it in your head, you don't know, right? So, no. When you first started learning your multiplication tables, what'd you do? You wrote them down. Okay, so this is the base, this is the fundamental step of how to solve an equation. I know some of them are simple, but you're going to write the step down. So on Friday, when we get to the complicated equations, you will know how to do the three different steps that you have to do to solve the equation. Okay? You must show your work. You must show it just like I've done there. Obviously, you don't have to draw the scale, but this part of the problem right here, and I'll show you another example that you have to do that. Okay, now, let's look at this one. Y plus 13 equal -17. Once again, I said earlier that they're going to have both positives, they're going to have negatives, they're going to have adding, they're going to have subtracting, they're going to have subtracting negatives, adding negatives, all the things that we've done in Chapter 6 and up to this point in Chapter 7 is going to be in this. Okay? Now, obviously here we're adding. So the inverse of addition is subtraction. So I'm going to take y plus 13 minus 13 equals -17 minus 13. Now, here's the problem that most people run into. They don't follow their steps for adding and subtracting negatives. Okay? Right here, these two cancel out. On the left side, they cancel out. On the right side, I have this. Negative 17 plus negative 13. The reason I have that is because we must change all subtraction problems to addition problems and do the opposite of the number behind the subtraction sign. Okay? Now, we didn't have to do that up here because that's just a regular subtraction problem that you've been doing since, first grade. Okay? When it includes negatives in your problems, then you've got to, the only thing we know how to do is change subtraction to addition. You don't have a rule to do negative 17 minus 13. You don't have a subtraction rule for a negative. The only thing that we have is we have a subtraction rule that says change all subtraction to addition, do the opposite of the number behind the subtraction sign, and then follow your rules for adding integers. That's what we have a rule for. Okay? So, having said that, I have negative 17 plus negative 13. Jesse, what is negative 17 plus negative 13? Negative 30. So y is equal to negative 30. And that is your answer. That is how you must show your work. Okay? So far, the two that I've done had addition in them to begin with. Let's look at one that has subtraction in it to begin with. Let's look at this one. H minus 9.3 equals 28. H minus 9.3 equal 28. Now, remember when you're adding or subtracting decimals, you must line up the decimals. Okay? Where is the decimal in 28? After the 8. That is correct. Okay? Obviously, it is not there at this time, but here in a minute when we go to subtract it, add it, whatever we're going to do, then we must, put it there and line them up. Now, obviously in this problem, we're subtracting. Okay? It's first thing we must decide is what are we doing to the variable? What are we doing to h? We are subtracting 9.3 from h. So the inverse of subtracting 9.3 would be to add 9.3. So we're going to add 9.3 to both sides. Okay, on the left side of the equation, they cancel each other out, leaving me with h equals. On the right side of the equation, I have 28 point and 9.3, and I add them together because they're both positives. How did I get 28? That's what the problem said.
Like, if we're adding, how do they cross each other out?
Okay. If you subtract, if you have 20, okay, what's 20 minus 9? What's 11 plus 9? Don't you end up with the same number? If I take $10 from you, but then I give you $10 back, that would be subtracting and adding it, correct? You ended up with the same amount of money, right? Okay. So anytime you do the inverse, that's what the mathematical rule is for inverse. Anytime I do the inverse of subtracting, I have to add. And they will cancel each other out. Whether it's a decimal, fraction, doesn't matter. If I'm subtracting something and I do the addition of that same something, then it will cancel each other out. Now on the right side, obviously it doesn't cancel itself out because you're not doing the inverse. You're actually adding to the equation to make it equivalent. Okay? So when you add those two things together, you get h is equal to 37.3. Okay? All right. Number 15. You have negative 5.1 is equal to x minus 14.2. Okay? It does not matter that the x is on the right side now instead of the left side. The process is still the same. What are you doing to x in this problem? Somebody raise your hand. Somebody raise your hand and tell me exactly what you're doing to x in this problem. Gabby. I'm subtracting what? No, I'm not subtracting x. What am I doing to x? I'm subtracting, right, I'm subtracting 14.2 from x. So the inverse of subtracting 14.2 is what, Cameron? Adding, thank you, adding 14.2. So I'm going to take to both sides, and I'm going to take negative 5.1. I'm going to add 14.2 to it. Then I'm going to take x minus 14.2, and I'm going to add 14.2 to it. Okay? On the right side of the equation now, on the right side of the equation, subtracting 14.2 and adding 14.2 cancel each other out. Okay? On the left side of the expression, we have a positive and a negative. So we must take the absolute value of those two numbers and subtract their absolute value. Okay, so that means 14.2 minus 5.1. That's the absolute values. The absolute value of negative 5.1 is positive 5.1. The absolute value of positive 14.2 is positive 14.2. I take the larger number and I subtract the smaller absolute value from it. That's why it's 14.2 over 5.1. Since we're subtracting decimals, you must also line up the decimals in both numbers before you can subtract. Now we subtract it. 2 minus 1 is 1. 4 minus 5 I can't do. 14 minus 5 is 9. So x is equal to 9.1. It is positive 9.1 because the larger absolute value is the 14.2. And so therefore I must keep that sign, which is positive, that's with the 14.2 in my answer. Gabby.
Why did you add 5?
Why did I add?
I mean, not like put it in.
You have negative 5.1 plus a 14.2. So let's forget that it's an equation. To simplify that expression, what do I have to do? Well, it's a negative and a positive, so that means my rule is when you have a negative and a positive number, in this case a real number, not an integer, when I have a negative and a positive, I must subtract their absolute values. Just like if that was negative 5 plus a positive 14. What would you do? 14 minus 5, right? And then keep the positive sign. Well, just because we put decimals on the end of it doesn't change our process or our rule. The rule is still the same, whether it's a fraction, whether it's a mixed number, whether it's a decimal. We're just now dealing with real numbers as well as integers. You're used to just seeing integers, which is a whole or counting number that's positive or negative. Now we're going to see all of them. Okay, in these last few sections of Chapter 7. Excuse me. Tayshawn. If you put the answer like that, no, that is fine once you get the answer. Okay, you don't. It's hard to do up here. You can do it, but you have to be very careful because there are certain times that they're going to have some. You have to be very careful if you do it up there at the top because you can occasionally mess up a negative or a positive sign. Sit up. Lily, this is not Miss Jordan's class. You don't do math in her class. You're not going to do art in mine. Okay, any other questions? Trinity, did that answer your question? Okay. Yes, Quade, can I help you with your question now that you've already spoken before I've given you permission to? Need a few more watches? Okay. What is your question? Yep. I didn't, because you have to borrow. You can't do 4 minus 5. I borrowed from that one because I can't do 4 minus 5. Okay? And so that just, I didn't finish it out. That's 0. And I added the 1 to the 4, which made it 14. Okay? All right. I want you to try this one on your own. R plus 10 equals negative 10.2. R plus 10 equal negative 10.2. I'll give you about a minute to do that one. All right. R plus 10 equal negative 10.2. Okay. I am adding 10 to R. So adding 10 to R, the inverse of that would be to take R plus 10 minus 10 equal negative 10.2 minus 10. Now, on the left side, the plus 10 and the minus 10 cancel each other out, leaving me with R. On the right side, we have negative 10.2, change the subtraction to addition, do the opposite of positive 10, which is negative 10. So now I have negative 10.2 plus negative 10. Okay, well, they're both negative, so I simply add the two together. So that's 10.2 plus 10. That's going to give me 20.2, but both of them are negative, so it must be a negative 20.2. So your answer would be R is equal to negative 20.2. What doesn't make sense? All right. Move to a little harder one. 5.7 is equal to 9 plus P minus 1. Okay, now, two different ways that you can do this problem. Okay, they both will yield the same answer. Okay, the first thing that I can do is on this side, I need to simplify that part of the problem first, because I have two constants on that side, 9 and 1. If I'm going to do that, however, I must do this. 5.7 is equal to 9 plus P plus negative 1. So I changed my subtraction to addition, and now I'm going to use the commutative property. The commutative property says I can do this. I can rearrange the terms now that it's all addition. I can rearrange the terms, and I can put 9 plus negative 1 together. What is 9 plus negative 1? 8. So I have 5.7 is equal to 8 plus P. Now I need to solve it. Solve by using the inverse. Okay, we solve by using the inverse. So that means 5.7 minus 8 equals 8 minus 8 plus P. Because I was adding 8, I did the inverse to both sides, which is subtract 8. Okay? Now, I have the 8's on the right side canceling each other, leaving me with P. Then I have 5.7 plus negative 8. I have a positive and a negative, so I must take their absolute values. So, the absolute value of negative 8 is what, Jesse? 8. And then I have the absolute value of 5.7, 5.7. Okay, so I'm subtracting their absolute values. Now, I have to borrow, making that a 7, making that a 10. 10 minus 7 is 3. Bring down my decimal. 7 minus 5 is 2.3. The larger absolute value is the negative, so I must bring it down into my answer. We're adding a positive and a negative, which means that we're subtracting their absolute values. I had to borrow. Had to borrow. Huh? Right. I can't go 0 minus 7, so I had to borrow. Make it a 7, make it a 10. All right. Let's look at this one. 26. 7.2 is equal to 4z plus 3 minus 3z. Yeah, we're doing 7.2, 4z through 3z. Yeah, and we're gonna add 3 more in there. All right. Now, once again, this needs to be simplified. To be simplified, we must change all subtraction to addition. So that's 7.2, 4z plus 3 plus negative 3z. Now I can use the commutative property. 7.2 is equal to 4z plus 3z, negative 3z, plus 3. Let me make that a little... Okay, now, the 4z plus negative 3z, you can put together. What is 4 plus negative 3? 1, and that's 1z. So 7.2 is equal to 1z plus 3. Now I can solve. Now I solve by using the inverse operation of adding 3. What is the inverse of adding 3? Subtracting 3. So I'm going to say 7.2 minus 3 equals z plus 3 minus 3. The plus 3 and the minus 3 cancel each other out. What is 1 times z? What is 1 times z? What is any number times 1? Itself. So 1 times z is just z, so there's no reason to put it. I can, and it doesn't change the answer. Okay, so what is 7.2 minus 3? 4.2. So 4.2 is equal to Z. Minus, if you got $7.20 and I subtract $3 from it, gives you $4.20 left over. That is what 7.2 minus 3 is. Okay? So your homework. Your homework is 7.3, 2 through 26. It was originally 10 through 26, but you yapped too much. No. Actually, I added 9. Get to work. You still got 8 minutes left in class.